Hey everyone, thanks for being with us today. This is Math from the Void, math coming at you out of nowhere. Today we have a problem from the 1993 exam, the AB exam, and we've featured a problem that is similar to this on the channel. It's similar in that it's cubic and it's missing the constant term. So this is going to be a test of your understanding of cubic graphs. And we're going to be able to do lots of calculus with this without a problem, because once we take a derivative of the function, we're only going to have x values. We're no longer going to have k. So let's address this starting with part A. On what intervals is f increasing? So increasing means f prime is positive. The slope is positive. So let's set f prime, which will be a quadratic function, yes, because f prime is the derivative of a cubic. That's going to knock it down to a quadratic. 3x squared minus 10x plus 3. Now, when is this equal to 0? This could be factored. Looks like we're going to have 3x minus 1 times x minus 3. And that's going to be equal to 0. Let's move this stuff just a little bit. Oh, it's going to be difficult to do that. Well, maybe let's just move. Okay, we'll just carve out some space for that. So our two zeros are x equals 1/3 and x equals 3. However, how do we know when it's increasing? Well, we could use the chart. But it's even easier than the chart, because if you know what the cubic function looks like, it generally looks something like this. Right? The parent function is x cubed, but generally when we have other terms being added or subtracted, we get more of the wavy shape. And so when is this increasing? Well, as you can see, no matter what the k value is, it's going to be increasing up to this maximum point, which is going to occur at the smaller x value of the critical numbers. So in this case, let me actually move it into a decent place. Maybe something like that, because the first spot is 1/3, and then the next flat spot is 3. Now we don't know how high up the graph is. That depends on the k value. But this gives us a very good understanding of what the shape of this graph is like. And so it's increasing clearly from negative infinity to the 1/3. And then it's going to go down, right? It's going to dip downwards. And then later it's going to go up again. That's going to be from 3 to infinity. That's when it's increasing. Very simple. Similarly, on what intervals is the graph of f concave downward? So now we're looking for when f double prime is negative. Okay, so let's take another derivative that's not going to be too hard. F double prime is going to equal 6x minus 10. And if we set that equal to 0, we get that x equals 10 over 6, or 5/3. Now, when is it concave downward? We could do something clever and take a look at this graph here, 3x squared minus 10x plus 3. That's a quadratic. It's a positive quadratic, so it's going to look like this. So this is a graph, a sketch of the derivative. And you notice that it has a flat point here, right? So we're finding that flat point. That flat point is at 5/3. A graph of this would look something like that. And so this function, this derivative, or rather this second derivative, is negative whenever x is less than 5/3. You can see that this is decreasing all the way until 5/3. That's the derivative of the function, and it's 0 at 3 and 1/3. But if I look at the second derivatives graph, it is 0 at 5/3, and then it's negative to the left, it's positive to the right. You could also throw these things on a chart. So we're looking for when it's concave downward. That means the second derivative is negative. That's going to be from negative infinity to 5/3. Okay, and that kind of matches up with what we would expect the sketch to look like at some point, which happens to be here at 5/3 on the original function. We get the concavity change, right? It's like a sad face until this point of inflection, and then it goes upwards like that. So we have a decent sketch of what it looks like. If we wanted to know what y value that was located at, we would have to plug in 5/3 to the original. But it's not asking for the point of inflection. It's just asking for us to determine where it's concave down, which is when the second derivative is negative. We don't have to focus on that turning point from negative to positive. Okay, part C. Find the value of k for which f has 11 as its minimum. So this is a y value, 11. And if we take another glance at the sketch of the function, that would mean like this lowest spot is 11. So probably everything's lifted up much higher than we have it here. Let's see if we can... What's an easy fix for that? I guess it would just be like doing that. Yeah, but now we don't have to do that. We can keep it the way it was. Okay, so this is the y value at the relative minimum. What x value is the relative minimum? It's 3, right? We had 2 spots with the critical points, 1/3 and 3, but we know because the shape of the graph, or if you throw it on a sign chart, you can see that this 1/3 is going to have a maximum at that x value, and this 3 is going to have a minimum at that x value. So let's plug in 3. See, it says at its relative minimum. It doesn't really tell you, but you have to realize from the past work that you've been doing on this problem that occurs at x equals 3. And if you had a sign chart for it, you'd be fine with knowing that. All right, so let's plug 3 into the function. F of 3 is going to equal, was it x cubed or 3x squared? I guess it doesn't matter because it's the same value, but x cubed minus 5x squared, so 45, that's 5 times 9, plus 3, which is 9, plus k, equals 11. That's it. That's all there is to it. You just solve this very basic equation here. So we have negative 9 plus k equals 11, and so k equals 20. All right. So that's the location. Yeah, it's basically just having you find the y value. It's having you find the relative minimum in a sense. Well, no, they give you the relative minimum, but it's having you set up the same equation. This time we're missing information about the function, the equation of the function, and we know something already about its value. So it's similar to if they gave you a function and had you determine what the minimum was, but it's a little bit more work because you have to think a little harder. Okay, so this was from 1993, something from back in the day. You should get used to these cubic functions and how they are generally shaped, and then you can attack questions like this with missing values. The better you get at no numbers problems, the better you're going to be on the AP exam. So thanks for your time here. Rewatch the video if you need to, as much as you need to, until you get very comfortable with these questions. You should be extremely comfortable with these questions before you take your AP exam. All right, catch you next time in the void.